Hey guys, Physics in the Flesh is back with another circular motion problem. Our sun rotates about the center of the galaxy, mass of which is about 4 times 10 to the 41 kilograms, at a distance of about 3 times 10 to the 4 light years, where 1 light year is 9.46 times 10 to the 12 kilometers. What is the period of our orbital motion about the center of the galaxy? Okay, so I'm going to draw a picture to get us started. Okay, so you've got your galaxy. I think we actually have 2 spiral arms, although when you look from far away, it almost appears like 4. Regardless, there's our galaxy. Here's our sun. Okay, now the distance between the sun and the center of that galaxy, we'll call it RS. The mass of the sun, let's call it M subscript S, and the mass of the galaxy has been given to us as capital M subscript G. Okay, so here are some of the quantities we know. Something else that immediately pops out to me in this question is that the conversion for light years to kilometers, we have to change that to meters. Okay, so because there's 1,000 meters in a kilometer, all you have to do is change this number to a 15 to make it meters. You multiply it by 1,000 or you add 3 zeros. Hence, you increase the exponent by 3. Okay, so 9.46 times 10 to the 15 meters is 1 light year. Okay, so here's what we got going on here. We've got the sun orbiting around the center of the galaxy. Now, you might say, you know what, the mass of the galaxy is pretty much spread out amongst this whole area. So the sun is technically inside this mass. But remember that in a galaxy, the majority of the mass is concentrated within the center. This is where the old red stars are, billions and billions of stars. Okay, so assume that's where the majority of the mass is. So it's not a bad assumption to do this problem. Okay, but at the end of the day, we've got the sun moving in a circle, in other words, undergoing centripetal force via the force of gravity. So what I'm going to do is set Fc equal to Fg. Now, Fc, mv squared over r. That's what centripetal force is. And that has to do with the mass of the sun, the speed at which it's orbiting the center, and the distance of the sun to the center of the galaxy. Force of gravity. Gravitational constant, mass of the sun, mass of the galaxy divided by the distance between them squared. Okay, so hopefully this looks familiar so far. Now we can actually simplify this quite a bit. First things first, the masses of the sun cancel out. In other words, the mass of the orbiting object is irrelevant in this case. Okay, one of the distances cancel out, leaving us with an exponent of 1 there. So we're left with Vs squared equals G mg over Rs. Okay, now the reason I didn't write Vs squared here is because I want to replace it with something. Notice that in the question we're asked for the period of our orbital motion. We're not asked for speed, but we can get the period from the speed. Okay, and this is how we're going to do that. Remember from your basic understanding of kinematics that speed is found using distance over time. Now, when moving in a circular motion, the distance you undergo is that of the circumference of a circle of radius r. Okay, so 2 pi r, and the time to undergo a circular motion, and the time to undergo circular motion is called the period, t. Okay, now in our question we're dealing with v squared, so v squared is going to be 4 pi squared r squared over t squared. And if we want to make it unique to our problem, we're dealing with Vs, so Vs is equal to 4 pi squared Rs squared over Ts squared. Okay, so there we have it. This is what we're going to be plugging in to our formula. Okay, so let's plug that in over here. We've got 4 pi squared Rs squared over Ts squared. Now, we are concerning ourselves with isolating for Ts because that's what we're looking for, the period. So what I'm going to do is I'm going to take this and multiply both sides by Ts squared, essentially bringing this to the top right. Divide both sides by GMG, bringing that down here, and multiply both sides by RS, bringing that up here. So essentially, these two parts are going to switch positions, and the RS comes up here. So then we're going to be left with the following expression. 4 pi squared RS cubed, right, because the RS times RS squared gives you RS cubed, over GMG is equal to TS squared. Now I'm going to rewrite that so that the TS is on the left. It just looks nicer. It doesn't really change the math of the problem. And I'm going to square root both sides. So I have a simple expression for TS. Okay, so TS is equal to the square root of 4 pi squared RS cubed over GMG. And there you have it. I have my final expression. All that's left for me to do is plug in my numbers. Okay, so let's do that over here. So TS is equal to square root 4 pi squared. Now, RS, the distance between the sun and the center of the galaxy. Okay, we've been giving that distance in light years, 3 times 10 to the 4 light years. Okay, so D is equal to 3 times 10 to the 4. Now, in our calculation, we have to enter it in meters. We have to enter it in SI units. So I'm going to multiply this by 9.46 times 10 to the 12, or rather 10 to the 15 meters is equal to 1 light year. And when I do that, my light year units cancel out, and I'm left with this number times that number, which will give me the distance in meters. Okay, so you end up getting the distance is 2.84 times 10 to the 20 meters. And that's what I'm going to plug in. This is going to be my RS. Okay, so let's plug that in over here. So 4 pi squared RS cubed, so this number 2.84 times 10 to the 20 meters cubed divided by G, 6.67 times 10 to the minus 11. And obviously there are a lot of units that go along with that, but right now we just want to plug in our values because there's nothing else that's going to cancel out at this point. Mass of the galaxy, 4 times 10 to the 41 kilograms. Plug those numbers in your calculator and you're going to end up with a time of 5.8 times 10 to the 15 seconds. Now, we don't want to quote the time it takes for the sun to orbit the center of the galaxy in seconds. It's a really big number. Let's express this in years. Okay, so we know that 1 year is equivalent to 3.15 times 10 to the 7 seconds. If you're not sure how to go about that, leave a question in the comments below and I'll answer it for you. But essentially, you're doing 60 minutes, 60 seconds in a minute, times 60 minutes in an hour, times 24 hours a day, times 365 days a year. And you end up with this number. Obviously, it's technically 365.25, but we're estimating here. Okay, so our seconds cancel out. We're left with the unit of years. Divide these two numbers, and you're going to get TS to be 1.84 times 10 to the 8 years. And we have to express this to 1 sig fig because the least certain measurements in our question are given to 1 sig fig. So we are going to round this up. So we're going to end up with 2 times 10 to the 8 years. This is how long it takes the sun to go about the center of the Milky Way once. Okay, so that's it for this video, guys. I hope you enjoyed it. If you did, be sure to smash that like button and subscribe to my channel so you never miss a video from Physics in the Flesh. I'll catch you guys in the next video, number 96.